All right, guys, so like I said, this is going to be our very last lesson for the year. Get excited. But our last lesson is going to be how do we graph these lines if we have our slope-intercept form from our last video. So there are basically 3 steps for how to graph a line in slope-intercept form. Step 1, you graph the y-intercept on the y-axis. So being able to identify that y-intercept like we did in the last lesson is important. It's always going to go on the y-axis. Step 2, you're going to rise and run with the slope to graph additional points. So being able to identify the slope, again, why we did that in the last video. Third step, you're just going to connect your points and form a line. Okay, so I'm going to go through these 3 steps on a couple examples. So the first one is actually number 16, says y equals 2/3 x plus 1. So the first thing that it said to do was to graph the y-intercept on the y-axis. So remember, your y-intercept is this value at the end. So my value here is a plus 1. So remember, your y-axis is the axis going up and down. So on that y-axis, you just want to put a point at positive 1. Then it says rise and run with the slope. So my slope is this 2/3 value. 2/3 value, rise over run. So from that dot you put at positive 1, you're going to rise 2, meaning count up 2 spaces. So 1, 2. Then you're going to run 3. So go to the right, 1, 2, 3 spaces. Put another dot. You can do that multiple times. So I'll do it again. Up 2, 1, 2, 3 to the right. Once you have 1 or 2 extra dots, then you can take your pencil and you can connect your dots into a line. So if I start here and take it a little bit further than your dots, okay, and then we can put our arrowheads at the end. That tells us that that line goes on forever, okay? So I'm going to take the same approach over here to number 17. Y equals a negative 3x plus 4. So again, we always start with that number added or subtracted at the end. If it's a plus 4, that means we're at positive 4. If that had been a negative or a minus, just realize that would put you down here at the negative numbers. If you have a whole number for slope, put it over 1. Let me fix that since my marker was on the fatter setting. It's not very clear. Put it over 1. There we go. You always want it to be a fraction. That way you have the rise and the run available. Your top number might be negative like it is here. That means you count down instead of up. But the bottom is always going to have you counting to the right. So here from my dot, I go down 3 over 1, put a dot. And I can do that more. Down 3 over 1. Down 3 over 1. And again, you can do that as many times as you want. The key being is once you have a couple dots, we connect them with our line and we put our arrowheads. Okay. This one says y equals a 1/2 x minus 3. If you want to give it a shot, hit pause. If you need to draw a graph quick, draw a graph. Or even if just you want in your head, just sort of visualize, where is this line going to start? What's my rise? What's my run? That works too. So I'll give you a moment. And I'm going to unveil the graph. So this had a y-intercept at -3. So I'm down here at -3. Rise 1, run 2, rise 1, run 2. So I did that a few times, connected, and put my line with arrowheads at the end. Okay, so that's how we graph from slope-intercept form. But one of the things that we learned in the last lesson is sometimes my line isn't written this way to start with. Sometimes I'm responsible for getting y equals mx plus b in the first place. And so that's what we're looking at here. What am I doing, or what's my equation? So here I have my y, but it has that extra 2x, right? So we're going to subtract 2x from both sides so that y equals a negative 2x plus 4. And so if y equals a negative 2x plus 4, understand if your slope is not a fraction, you might want to put it as a fraction first. And so that means I can now move on to my graph. So I have a plus 4. I'm going to start at plus 4. My slope is negative 2 over 1. So I'm going to, from my positive 4, go down 2 over 1, down 2 over 1. And again, you can do that as many times as you want. I could go the whole way to the edge of my graph. I normally do it at least 1 or 2 extra times, mainly so that when I go to draw my line, I have more dots to connect. So my line is going to be a little bit straighter. It's not going to wiggle all over my graph. And it just makes it a little bit more clear exactly where that line goes, rather than just two dots that might be pretty close together. So if I take the same approach now to number 20, I have this extra minus 5 that's in the wrong spot, so we're going to add 5 to both sides. Y equals a negative 2x and a positive 5. I'm going to again put my slope over 1, and then I'm going to start graphing. So I have a plus 5. That means I'm starting at positive 5 on my y-axis. Let me fix that. There we go. And then I have negative 2 over 1 again. So once again, I'm going to go down 2 over 1, down 2 over 1. And again, the negative is telling me to go down. You're always going to be counting to the right. And we're going to connect our dots. There we go. And if you want one more, here's one more. If you want to hit pause, do it yourself. At least maybe solve for y. Maybe do that first. So I'll give you a moment. And so here's what we're looking at. First thing I would do is I had this plus 5x, so I subtract 5x from both sides. Negative 2y equals negative 5x plus 6. Can't have this negative 2 with my y, so I divide everything by negative 2, just like we did in the last lesson. Divide everything. Negative 5 does not divide by negative 2, but a negative divided by a negative is positive, so I do have a positive 5 over 2 as my slope. 6 divided by negative 2 gave me negative 3. So when it came to graphing, I start at negative 3, pop my dot, right? From negative 3, I'm going to rise or count up 5. So from here, 1, 2, 3, 4, 5, over 2. 1, 2, 3, 4, 5, over 2. Connect your dots, make your line. Okay, so this is how we graph lines that are sort of diagonal on our graph, some positive, some negative. But the key is there are times where we can have lines that go straight up and down or straight left to right. So how do we get vertical lines and horizontal lines? So real quick, just want to point out that a vertical line would be straight up and down like this. A horizontal line would be straight across like this. Okay, so how do we get those? Vertical lines have undefined slope, if you remember that from before, and horizontal lines have those slope of zeros, right? So that's why vertical is undefined, slope of 0, remember. Undefined slopes happen when your equation is x is equal to a number, and slope of 0 happens when y is equal to a number. And that's all your equation is going to say. So when you look at something like these two problems on my paper, or on your screen rather, y equals negative 2. Go to your y-axis, find a negative 2, and put your point, okay? The idea is if this is on my y-axis, I don't want to just trace my y-axis because that means if this number changes, the line doesn't change. So because my dot is on the y-axis, I flip and my line goes the other way. And here's that dot at -2 still, okay? When it says x equals a number, so x equals 6, then on the x-axis, and these are the only problems you will ever start on the x-axis, here's x equals 6. Again, I don't want to trace the x-axis, so I sort of turn and go the other way. Here is my vertical line going through that x equals 6 point, okay? This is how you get vertical or horizontal lines. So real quick, if you want to graph these, go ahead. If you just want to sort of picture in your head which one of these is going to go from left to right, which one of these is going to go up and down, where are they on the graph, right? Where would you put that starting dot? So x equals -4. On the x-axis, I put my dot at -4. I turn, and so my line goes up and down. On number 25, y equals 3. So on my y-axis, I go to +3, but then I turn and I draw my line going from left to right. And so that is how we get vertical and horizontal lines. And in total, this whole video is how we graph lines from our equations.